With an unprecedented number of cyber threats out there, protecting data is top of mind for all businesses. Today, we're going to be talking about a way to encrypt data at the source, in transit, and at rest. We're going to be talking about confidential computing, so stay tuned. Hey everybody, this is Chris Brandt. Welcome to another FUTRtech video podcast. Today, we are talking with Fortanix CEO and founder Ambuj Kumar. Fortanix is the industry leader in confidential computing. They decouple data security from infrastructure, which allows businesses to centralize control of their secure data across their on-prem, cloud, and SaaS platforms. Now, they've raised over $45 million from prominent investors like Intel and Foundation Capital. And Ambuj is going to tell us what confidential computing is, how it works, and what it can do for you. Welcome, Ambuj.
Thanks, Chris, for having me. Really excited topic.
Yeah, thanks for being on. I think this is a really interesting area. You know, so many businesses are just getting crushed on the security front these days, and they are all looking for ways to better protect their data. But before we get to that, can you just give me a little bit about, you know, sort of the founder story with Fortanix? Like, what was it you saw in the market that you're like, wow, this is a need that needs to be filled as soon as possible?
At very high level, we continue to see security challenges all over the place, right? Organizations are getting breached every day. Individuals are getting more educated, certainly, about security threats with ransomware affecting them personally.
Yeah.
And as societies get richer and more prosperous, amount of time and energy that we will spend on securing our digital lives, that is only going to go up because we have more things at stake, more things to protect. So what it also does is it attracts lots of attentions from hackers and bad guys, and there is clearly a very significant, important race going on between bad and good and evil and others. And what I saw was most of the security companies, most of security products, they were designed by people who had their career in networking companies. So they have certain perspective. They try to keep the infrastructure secure. They try to make it harder for bad things to get in. So think of like firewalls, SIM tools, log tools. Idea is that there is something that is good, and you create some kind of perimeter, virtual or physical, around it. And then you are keeping bad things out. But in today's distributed, interconnected world, it was just getting harder and harder every year. So our approach was that, hey, we will assume that we are compromised. We will assume that bad people are all inside your network. Bad packets are there. What can you do then to keep your data secure? So that is how Fortanix got started.
That's awesome stuff, and I'm sure it also is touching into the zero trust world too, because what you're talking about really is you don't have to worry about what's happening inside your network because everything's secured as it is. But tell us a little bit about, we hear this term confidential computing, and you guys are obviously the industry leader in that. So what is confidential computing?
So confidential computing has a very simple premise, which is that you don't have to trust the cloud provider, you don't have to trust the infrastructure, you don't have to trust operating systems to keep your data secure. Mm-hmm. And the way confidential computing operates is we create a secure enclave, which is a protected region in memory using hardware constructs. So CPUs help you build that enclave. It's a virtual entity where your application gets loaded and all the data that your application processes is encrypted outside that enclave. So if you get somebody to click on a wrong email, or somebody downloads a bad software, or there is a privilege escalation vulnerability in the system, and even other bad applications are after your data is encrypted everywhere outside that enclave. So that is encrypted. You don't lose anything by somebody having access to that data. And your data is decrypted and processed only inside enclave where hardware ensures that no unauthorized software can access your data. So confidential computing is a new type of computing where hardware-assisted features allow you to keep your data protected, encrypted outside a very tiny entity called enclave. And who gets inside the enclave is very carefully monitored using hardware instructions. And that's how you can keep the entire software vulnerabilities outside your scope.
In past lives, I've managed root certs and things like that, and we used like hardware security modules inside of computers to kind of create that enclave. But you guys have taken a little bit of a different approach because that kind of approach doesn't scale at all, right? I mean, it's like one box, one card, right? And but like nowadays we have to secure both things on-prem, in the cloud. You have to secure data that you're sharing with SaaS providers and things like that. So you guys have a little bit of a different approach to how to secure all that data. Could you talk to how you guys approach that?
Yeah, hardware security modules certainly are useful, right? It's a physical 1U box that is like kind of bulletproof, foolproof. If somebody tries to break into it, it will delete all its keys and nobody can get your data. But if you think about why you needed hardware security modules, it is because you have some sensitive data, namely your keys, your digital keys that you put inside that hardware security module, and you do not trust the outside environment or your data centers or your system operators. And so you want to ensure that, hey, even if my system operator is compromised or a bad software is downloaded in my data center, at least my keys will remain secure. So that's why and hardware security modules are notoriously difficult to operate, very expensive, unwieldy, right?
Very, yeah.
But you suffer through all that pain because you don't want to lose your keys, which are which can unlock like almost all your data.
Yeah.
But then if you want to go to cloud or like you operate 20 different data centers or POPs around the world, then like putting HSMs, hardware security modules, in those locations is almost impossible.
Yeah.
So our approach is software driven, right? So we use enclaves assisted by Intel SGX, AMD, ACV, and other technology, and it offers not similar but increased protection of security compared to hardware security modules. So much so that we got similar 140-2 level 3 certification from NIST and all other security protections. But since it's in software, you can consume it as a SaaS. So you don't need a PhD in cryptography to secure your keys, right?
Yeah.
Since it's in software, it is available in cloud. So you don't have to go and purchase a box and provision and rack and stack and assign network addresses. But much more importantly, you are not limited to just keys. You can secure a whole variety of data, right? So you can secure your SaaS data, you can share your data with somebody outside your organization and ensure that they can use that data only for the right purpose. You can have some PyTorch AI application process your data and ensure that your data will never be compromised. So it opens up lots of possibilities because you move from physical piece of hardware to software that offers, in fact, increased security level.
So you touched on something I think that's really interesting, and like now once you sort of abstract away the physical hardware pieces to secure your stuff, and you said you have FIPS rated gear here that you're working with, so that's pretty impressive because that's a pain in the ass to get sorted out, I imagine. But I think the thing that's interesting is that you in a world where we have so many purposes for our data, and we're talking about data lakes, and now the concept of the data mesh, and all that, and data being sort of available in a more public kind of way. What you're talking about is you can have cryptographically secured data that you can share with other people and maintain that security and then revoke that security potentially even at any point, right?
Yeah, it's incredible. So the analogy I draw is for doing research for, let's say cancer treatment. So if somebody asks you that, hey, do you want to contribute your personal data for cancer research, I will assume answer would be yes, right? Who is not interested in solving cancer?
Right.
But the trouble is, once you submit your data, you don't know how your data will be used, right? It might be compromised, it might show up on dark websites, it might be used for unauthorized purpose. So instead of you helping some cause, you become a victim. So definitely making sure that you can put data to right use without letting go control of it. It is probably one of utmost important problems to solve for our time right now.
Yeah.
Because you do unlock lots of things that were previously unthinkable. So what we do is we take the data that you want to contribute, that you want to share, we encrypt that data, and then the keys for that encrypted data is not revealed to anyone. Rather, there is some application that wanted to consume the data, and you wanted your cancer research application to have access to your data. So that application is loaded in Enclave. It gets fingerprinted, and then if the fingerprint is right and as expected, then you send the keys for the data that you wanted to share to that application. Mm-hmm. And so that application can use your data. It runs as is, nothing changed. But anybody else, including people who are operating that application, they will never get to see your private data.
And we spoke about this a little before. One of the things that people have been talking about for many, many years, but I haven't really seen any real practical use of it yet, is homomorphic encryption. Really, right? Which is the idea that you can take encrypted data, do analytics against it without ever decrypting it, and still have useful analytics come out the other end, right? It's been a really interesting concept, but in practical reality, I don't think we've seen it, ever really working. This is sort of you kind of achieve some of the same goals here, but you're kind of taking a different approach, right?
Yeah, indeed. I mean, one of my mentors early on in my career told me that good engineers build tunnels through mountains. Great engineers avoid that. So
yeah.
homomorphic encryption is like building that tunnel through concrete wall.
Yeah.
And you are making progress 1 inch at a year rate. Yeah. Eventually it will happen. But the needs are so urgent, so important, like 8 billion, 10 billion people are counting on us to, solve diseases, anti-money laundering is real, people are doing all kinds of crazy stuff in interconnected digital world that you don't want, to wait for that tunnel to complete while, you take the shortest path. It's okay if it's a little bit, winding, but it will take 5 minutes extra, but it will get you there. So yeah. Homomorphic encryption is early, in its research cycle, and like lots of people are focused on that, and I hope it comes through. But that is certainly decades away. Confidential computing, on the other hand, it uses hardware-assisted features, so it is slightly different approach, but you do get similar benefits where cloud provider or infrastructure providers, they will not be able to see your application or data. So you do get all the benefits without waiting for that tunnel to complete.
So why do companies need this? I mean, like, it sounds like you can solve for a lot of problems that companies have. I mean, like, what are typically you seeing companies are asking for?
Yeah, so look, number one mega trend in enterprise world today is cloud migration. And COVID has accelerated that, right? Only things that kept our sanity going for the last 2 years is all the, like social media and, like news, online news and, online
I'm not sure
videos.
That helped our sanity.
It helped our sanity, like we were able to talk to our family, etc. Yeah. And just imagine being locked down in a room. So kudos to people who suffered through a Spanish flu, etc., without losing their sanity. Yeah. Clearly, we were not that brave, or need not be that brave. Yeah. So if you want to move to cloud, it reduces your operational complexities. Everybody wants to do that. But the number one thing that businesses highlight is, that they don't want to lose control of their data. They don't want to be breached. They don't want, somebody else to have access to their data. And what we provide is exactly that. So customers can take their most sensitive data, encrypt it with Fortanix, go to cloud, ensure that they are using all native cloud services. But no unauthorized person, no unauthorized application will be able to use their data. And that is true even if cloud provider gets some paper from some government, because it is not a contractual legal obligation that they are operating under. It is technically impossible for cloud provider to get plain text data.
Yeah, I think I can see like the huge like companies that have regulatory or like heavy compliance requirements. It's funny because so many of these regulatory and compliance requirements specify encryption along the full data path, right? And so rarely do you see that fully implemented, right? Because it's difficult to achieve, and so I would imagine that this is something that would be really beneficial to those folks, right?
Yeah, exactly right. I mean, nobody wants to be in headline for their data getting breached, right? So
yeah.
Clearly the need is there, right? And security teams also get funded because boards and CEOs and everybody now understand the importance of cybersecurity. It is the implementation phase where they run into challenges because one, we do not have enough people who understand security, much less encryption. So if you are a CISO and you got $1 million budget to implement some encryption program, if you don't have people, what are you going to do, right? You won't even know where to start. And even in then, if you wanted to move to Google Cloud, then you had to use one specific stack. If you wanted to do same thing in Azure, you had to do another stack. And whatever data you had on-prem, now you had to do something else. What Fortanix does is we provide one unified platform that is really easy to use, SaaS, appeals to developers out of college. They don't have to have deep expertise in security, much less encryption. And so they can use the easy to use. They can have easy to use platform for on-prem and cloud and for SaaS, and it works really well. It scales well, appeals to multiple use cases. We make the desire was always there to keep businesses' data secure. We just make it much easier for them to achieve that goal.
Yeah, and I want to underscore, what you said there, like the idea of centralizing the control of all your secrets. There's a lot of value to that because, like you mentioned, what you do for on-prem is going to be necessarily different than what you typically do in the cloud or in the SaaS platform, right? And the ability to sort of centralize that, because you guys do a lot more than just sort of the confidential computing piece. I mean, I think you're kind of known for the confidential computing piece, but you do all sorts of key management and all the other things that go along with that too, right?
Yeah, exactly right. So confidential computing is a technology that we pioneered with Intel and Microsoft, and now we have dozens of companies in the consortium that we lead. But at the end of the day, encryption, confidential computing, key management, these are the tools that we have built. The businesses we talk to, they are looking for a solution, right? So they are coming to us with problem statement that, hey, we are moving to cloud. How do we do that while putting our sensitive PCI data in the cloud? Or I'm a European company. I'm using US cloud, but now there is Schrems 2 ruling that asks me to keep control of my data. Don't lose control to some US company. Mm-hmm. Or I need to comply with CCPA from California or GDPR, things like that. Or our AI use case that there is a new initiative on AML. There are two financial institutes, they are collaborating. How do we share data, etc. So those are the problems, and we provide a solution. And the specific components include key management, encryption, confidential computing, all other things. But those are the tools to which all work seamlessly together.
Yeah, and you mentioned you do tokenization too when like you're in the
Yeah.
PCI environments. That could be obviously very useful as well. So, so tell me a little bit. I mean, like obviously one of the things that we mentioned before is sort of this idea of like having the ability to share out data, and and specify who it goes to and how it's used and maintain control over it. And I think that's one really fascinating use case, because I think that the portability of data is going to become an increasingly great need for everyone, and like the ability to like successfully manage that is going to be really important. But what other types of use cases are you seeing for this? Because I mean, obviously, there's a lot of different things one could do with this, right?
Yeah, so one of use case that is near and dear to my heart is what we are doing with UCSF, University of California, San Francisco research team.
Mm-hmm.
So they actually wanted to solve cancer, and they have expertise
small
to do
small
that,
problem,
unlike
small
me.
problem.
Unlike me, unlike so. But they are in business of collecting patient healthcare data, and they wanted any researcher to come to them and be able to use that data, right? But how do you do that where you are not, compromising on privacy and secrecy of that data? And so we worked with UCSF. This project is now live, and it encrypts all the patient healthcare data that they want to share, and the data is always encrypted or tokenized depending on the context of that data. It only gets available inside Enclave when right AI application is running. Outside that little enclave, it is always inaccessible because it's encrypted. So that is one use case where somebody wanted to share data for some AI application, and it is HIPAA scope data. Another use case is with PayPal. PayPal, the large financial company, they are in middle of their multi-year journey to cloud, and so they wanted to move to Google Cloud. They had certain sensitive data, and they were finding out how could we use all the Google Cloud's native services without Google, seeing our data. Mm-hmm. So we worked with them, and working in partnership with Google, we did something called external key manager. And what it does is all the PayPal's data is encrypted with keys that live outside Google Cloud, inside Fortanix systems. And when Google BigQuery runs in runtime, it makes a call to Fortanix. We deliver a key, data gets decrypted. Query runs as if nothing happened. But if PayPal wants, it can revoke access, right, in real time for specific applications from specific locations. And otherwise, every single access coming from Google is logged, so they have complete visibility as well as control.
That's always been a really tricky piece, is sort of that data integrity piece, and like the fact that you have all the logs of the keys being shared, data being used, and like you can kind of have a complete data life cycle piece to that too. I got to imagine that's pretty valuable.
Yeah, indeed. Data has the full life cycle, right, from generation to termination. And especially in the context of GDPR, if somebody says that, hey, delete my data. Now, the problem is that data is probably archived and backed up, like 20 times.
Yeah.
In different systems, in different silos, and trying to figure out where all that data is it can be extremely hard problem in itself. So one of quick, things that we provide is, hey, encrypt all that data, right, as it's coming in, because it's PII data anyway. So, you are doing good right then. And you are archiving all the encrypted data. And if you want, erasure of data, when you get erasure of data request, you simply go and delete the key. Mm-hmm. And if the key is gone, then data is useless. And that does satisfy the requirement.
So with the UCSF example, and you mentioned that you're HIPAA compliant, right? Usually when projects work with data that falls under HIPAA, there's a lot of anonymization that goes on with the data. Do you satisfy the HIPAA requirements by keeping it encrypted in the enclave? so that they don't have to necessarily de-anonymize the data?
Yeah, that's a great question, right? So, that highlights why you need a unified system like Fortanix, right? So you have to comply with HIPAA, right? You also have to do best practices, and probably you want to do more than the bare minimum required by law.
Yeah.
So I will say that if I'm submitting my data for cancer research, nobody needs to know my name. Period. Right? It is not useful. So so the first thing that should happen is my name should be mapped one way to a string, right? So you can think of that as a tokenization. And you want to do that right at the source as you are collecting my data, because it's less burden on you, because if you forget my name, same thing, right? So you are doing some kind of tokenization for certain things, right? Like my name, because that is useless. You are doing some kind of eraser and data cleaning, right? I mean, you don't need to see my home address because there's nothing to do with that, right?
Right.
But guess what? My age, my ethnicity, my gender, all those things, my blood type, all those things are valuable. So you can't really tokenize them, right? So you need to encrypt them. And so you encrypt that piece of data, and you ensure that data gets decrypted only inside the enclave. And then there is some lots of unstructured data, right? Like maybe it's lab research or prescription or some lifestyle things, and those things are just used as bundle of bits that you encrypt, and you decrypt them only inside the enclave. So again, our solution first approach, what we promises to businesses is that doesn't really matter what kind of data you are collecting, you want to share, you will have full control of that data using tokenization, encryption, key management, confidential computing, whole bunch of things. But the end result is that you will always be in charge of your data. You will ensure that no unauthorized application, no unauthorized user, no unauthorized network packet will ever be able to see your data.
Yeah, when I first heard about your company, I heard it through a friend of mine, Ricky Villalobos. There are so many security companies out there right now, So like, my question to you would be is, what are you doing to attract talent? Because there's so many options out there. It's so hard to find good talent. What is it about Fortanix that you would want maybe potential employees or people that are interested in coming to your company? What is it that you think that they should know?
Yeah, that's a great question. So look, the fact that there are so many security companies out there is testimony to that there are so many security problems, and society is recognizing importance of this this problem. So that is a good start. And then like I always say that people are rooting for heroes, right? Everybody wants some company to break through and solve security. So we are a mission-driven company. We say that our mission is to solve cloud security and privacy. And of all the companies, we have a very unique approach. We were the first one to say that, hey, our approach is data, not infrastructure. We will decouple security from infrastructure. We will ensure that your data remains secure, whether it's on-prem, whether it's public cloud, whether it's SaaS, whether you are sharing, whether it is structured data, unstructured data, storage systems, data lakes, warehouses, whole bunch of things. So if you look from outside at very 50,000 feet view, it is really simple, promise that, hey, we'll keep your data secure, regardless of what kind of data it is. But if you try to, double click on that, then you certainly, you see all this complexity that, hey, I have, 100 types of databases, so many, data lakes. And, what does it mean to, secure data in Germany while the control is in California? So it's not easy problem to solve. But we have, more than 25 patents now. So it's a deep tech company. We have solved it. I'm very proud that, 100% of our customers are referenceable. We have now more than 100 customers in production. So we have reached that escape velocity where not only our product works, but our customer, our net retention rate is off the chart. So our customers are really happy, and that gives validation to us that, we know what we are doing. We are solving a valuable problem. And people get drawn to that, right? Because a talented, person in today's environment, they can find, 5 jobs in a week.
Yeah.
But it also gives them opportunity to ensure that, they do want to work with a company that is doing meaningful work.
Yeah,
So,
I really appreciate that answer. When we had the CEO of Lacework, Dave Hatfield, he gave a similar answer. I think this is not a technology problem. This is a people problem. This is a everybody's problem, right? Around the world problem. So I think there's become like this really good spirit, of security, right? As a salesperson, I want to make sure I'm selling things that are actually valuable and they're actually solving problems for customers, right? And in security, that's what I'm attracted to in selling security. It's like these are real problems. Unfortunately, it's extremely challenging problems, right? Like you're talking about encrypting just some of these databases and some of this data. How about all the data? Why wouldn't we encrypt all of it?
yeah, exactly right. Exactly right. And, if you look at like what is happening at global scale, right? Like North Korea and, other bad actors, it's a serious thing. So it's not, life is short. You only get to live once. This is most prolific time in history of technology, right? So many things being done. People are recognizing that there are bad actors funded by nations after your data. So it has to be very organized. It's not you put 5 tools, slap them together, and they will hold hold the border. No, so it's really a powerful product backed by a strong technology, innovative approach, and proof is in the pudding, right? So world's most sophisticated customers, including Fortune 10, dozens of Fortune 100. Lots of Fortune 2000 and a small mom and pop startups type companies all using our product. So on one end you have companies that have literally thousands of security engineers that use Fortanix. So they know they have ability to vet the product and make sure that it's really solid and does work before they take it. On the other hand, we have companies that have 20-30 employees. So it does not require army of people to operate. So when salespeople or engineers, when they see something like this, everybody wants to be part of that rocket ship, right? Yeah. Because if you are going to make money, why not make money with a company that might end up solving cloud security and privacy?
Exactly.
Small task.
A small task, indeed.
So what do you see next on the horizon for Fortanix? Like what's the next thing coming out for you guys?
Yeah, so there are multiple elements to that answer. One is on business. We'll expect to grow at similar rapid pace, so double, triple our business scale. And then number of employees we are expected to. Right now we have about 170, 180 employees. So in the next year or so we'll probably double, and that means building lots of new muscles, organizational structure, etc. So which is going to be very, very exciting. But fundamentally, we are customer obsessed company. So I would want companies to know and that there's a solution like Fortanix where they can adopt cloud without worrying about data security. Or some, European companies to understand that, they can comply with SREMS 2 or, other privacy regulations without, losing control of their data. So right now we just crossed our 100th customer mark. I want to, looking forward to get to 1,000 customers and, 10,000 customers and, ensure that all kinds of data that companies have, all that data can be protected, right? Really, just imagine what the world would look like if you were never worried about your data getting compromised. Mm-hmm. If you could share any kind of data you had with somebody else without worrying, somebody might misuse it. I think, we are just a means to that end, right? I mean, We are a data security company, but I do hope that, brilliant people out there, they use our technology and does remarkable things, right? Like solve all the diseases, ensure that no bad parties ever get funded, and things like that.
That's awesome. That's awesome. And I know that I was reading that you guys have like a conference or an event coming up on February 23rd too.
That's right. We have a webinar coming up on confidential computing, how you can use confidential computing for AI and other uses. And we'll have our customers and talk about the use case they are using. So you can ask any questions, talk to your peer group and learn a lot.
Yeah, and I'll add a link to that in the show notes too. Well, it sounds, you're tackling a big problem, and I think, in some ways it's not the most glamorous problem to solve, but it's a really important one, and that's kind of the big thing. And I think that, like I was saying, as data gets shared around more and more, the ability to control who has access to it, when and where, is going to be increasingly important. And I think you guys are well suited to solve for that problem. So, congratulations on that, and congratulations on your success to date, and, excited to see where you guys go tomorrow.
Thank you.
We're rooting for you.
Looking forward.
Yeah. Thanks so much for being on. I really appreciate it.
Thanks. My pleasure.
Thanks for watching. Love to hear from you in the comments. And if you like what you saw, please give us a like. Think about subscribing, and I will see you in the next video.